an object from interstellar space has been observed to visit our solar system.
A spaceship.
This is not a photograph.
What?
This is an artist's rendering.
In the year 2017, a mysterious object entered our solar system, and its shape was so strange that scientists had never seen anything like it before. However, researchers were astonished to find that this object was traveling at 3 times the speed of a typical comet in our solar system. The discussion about this object is extensive because it is the first interstellar object ever discovered in our solar system. In celebration of this remarkable finding, it was christened Oumuamua, a Hawaiian term signifying a messenger from afar that arrived first. Oumuamua was located 15 million miles away from Earth, which is approximately 62 times the distance between Earth and the Moon. What puzzled scientists the most was its velocity. While orbiting the Sun, its speed accelerated, challenging the principles of celestial mechanics. After this, debates sparked among scientists worldwide. Many started claiming that it could be an alien ship from an extraterrestrial solar system. Was there really a connection to an alien spaceship? Or is it a comet emitting gas in a way we've never seen before? And where is it now? Let's delve into the details and understand the mysteries surrounding this. You are watching the Cosmic Discovery YouTube channel. Join us as we uncover the secrets of this enigmatic visitor from beyond. The date was October 19, 2017, when the Pan-STARRS 1 telescope in Hawaii observed some unusual activity deep in outer space, far from our Earth. At that time, scientists had no inkling that it wasn't just a regular occurrence, but rather the birth of a significant mystery in the times to come. And that anomaly was Oumuamua. With a length of approximately 650 feet, resembling a long cigar, its biggest mystery was challenging some principles of the universe. Oumuamua wasn't a normal object. It was the first known interstellar object to traverse our solar system. Unlike the minor planets and comets generated under the gravitational pull of our Sun, Oumuamua, originating from the depths of interstellar space, hinted that it wasn't bound by the gravitational force of our Sun, turning it into a fleeting visitor in our system. What makes Oumuamua stand out is not just where it comes from, but also its unique features, its long cigar shape and swift rotation. These don't match the usual traits of objects we find in our solar system. Scientists are actively discussing and debating various theories about Oumuamua's nature. Is it a comet without a tail, a broken comet with an unusual spin, or perhaps something entirely new? These inquiries have ignited thorough scientific investigations, resulting in a range of hypotheses, from Oumuamua being a fragment of a larger celestial body to more imaginative suggestions, like it being an alien probe. The identification of Oumuamua marks a significant milestone in astronomy, akin to the moment when people first peered through a telescope and grasped that Earth isn't the center of the universe. It provides insights into the formation of our solar system and serves as a reminder that our solar system is just a small component of an expansive, yet to be explored frontier. As Oumuamua drifts into the distant reaches, becoming a faint dot in the cosmic expanse, the urgency to study it intensifies. It is our hope that, in the future, more sophisticated telescopes will gather additional details about these interstellar messengers, providing fresh insights into the makeup and history of the universe. Oumuamua was initially considered a comet by scientists, but it wasn't made of ice like comets, nor did it release gas as comets do. Its rotation, speed, and trajectory couldn't be solely explained by gravity, indicating it wasn't an asteroid. The shape and profile of this mysterious object don't match any comet or asteroid seen before. Oumuamua is a mile long, but only 114 feet wide. Researchers suggest that its frozen nitrogen composition could explain its shape. Another author of this research, Alan Jackson, mentioned that because the outer layer of this rock has dried due to the sunlight, its shape has become quite flat. It's similar to how a bar of soap becomes flat when it wears down. Its unique shape has led to various speculations, including the possibility that it's an alien spacecraft. Scientific papers describe the physical characteristics of Oumuamua in more detail. They mention the object is tumbling rather than spinning, which is unusual for both asteroids and comets. This tumbling motion could be the result of a collision with another planet. The path of Oumuamua adds another layer of intrigue. It entered our solar system at an exceptionally high speed, following a hyperbolic trajectory, ensuring it won't come back. Typically, objects influenced by a star's gravity adopt an elliptical orbit, but Oumuamua deviates from this pattern. Scientists suggest that non-gravitational forces likely affected its trajectory, possibly due to the rapid vaporization of materials. Yet, intriguingly, no visible gas releases were observed, deepening the enigma. The absence of a visible coma at the object's high speed has sparked various theories. Some scientists propose it might be a fragment resulting from a larger object's collision, while others speculate it could belong to a new class of objects, distinct from comets or asteroids. There's even discussion about the possibility that Oumuamua is a solar sail propelled by radiation pressure. Another notion suggests that the object's high speed could label it as a messenger from another star system, potentially ejected during the formation of a planetary system around a young star. This could position Oumuamua as one of the initial observed interstellar objects, a relic from a different part of the galaxy. The saga of Oumuamua unfolds like a cosmic detective story, where each clue only serves to deepen the mystery. Its elongated shape stands in stark contrast to anything observed in our solar system. Does this distinctive form hold the key to potential advantages for interstellar travel, such as reduced drag or enhanced stability? Alternatively, could it be the aftermath of a catastrophic event that eludes our current understanding? The trajectory of Oumuamua adds another layer to this enigma. The absence of a visible coma and tail eliminates the possibility of outgassing influencing its path. So, what non-gravitational forces are in play here? Could it be influenced by dark matter or some other yet-to-be-discovered cosmic phenomenon? The quest for answers continues. A new theory about the space rock Oumuamua has been presented in a paper published in the American Geophysical Union Journal. According to this theory, the asteroid was a piece of a small planet from another solar system. Astrophysicist and co-author of the research, Stephen Desch from Arizona State University, stated that we may have possibly unraveled the mystery of Oumuamua. We have logically identified that this rock was a fragment of a planet similar to a Pluto-sized planet in another solar system. Desch and his co-authors believe that about 50 million years ago, a space object collided with Oumuamua's main planet. Afterward, a piece of Oumuamua, a space object, broke off and entered our solar system. Scientists suggest that when this space object approached the Sun, its speed increased because the Sun's rays vaporized the icy outer layer of the rock, a phenomenon known as the rocket effect, similar to how comets gain speed. Was Oumuamua formed from nitrogen ice, like Pluto? The origin of Oumuamua's rock is unknown. Scientists have concluded that this space object is likely composed of nitrogen ice. It would be similar to the way the surface of Pluto or Neptune's moon Triton is formed from nitrogen ice. When this rock began approaching our solar system, the sun's rays likely started melting its frozen nitrogen layer. This space object entered our solar system for the first time in 1995. At that time, it went unnoticed, and as a result, about 95% of it melted, transforming into a silvery appearance. It was only in 2017 when astronomers discovered it, by which time it was already moving away from Earth at a speed of nearly 196,000 miles per hour. This left only a few weeks for researchers to study Oumuamua using various telescopes, yielding limited information. Now, this mysterious asteroid has traveled far from Earth, and with current technology, further investigation is not possible. Another theory suggests that Oumuamua could be an alien probe capturing the public's imagination. Its unique elongated shape resembling a cigar, coupled with its peculiar path, prompted discussions about the possibility of it being a man-made object. The notion gained popularity after Avi Loeb, an astrophysicist from Harvard, put forward the idea that Oumuamua could be a flat, thin, and nearly rectangular piece of material designed as a probe by an advanced alien civilization. This intriguing concept from Loeb garnered widespread attention in the media, fostering further speculation. Avi explained that Oumuamua reflected sunlight in a peculiar way, shining like a mirror every 8 hours. This suggested that it was rotating completely every 8 hours around its center. Such a rotational pattern hadn't been observed in any other space object before. Its brightness exceeded that of typical comets or asteroids by tenfold. The most significant claim Avi makes, serving as evidence for alien life, involves the influence of the sun's gravitational pull. He pointed out that objects approaching the sun usually accelerate, and those moving away decelerate. However, Oumuamua did not follow this pattern. Avi also noted that unlike comets or asteroids, Oumuamua didn't exhibit a tail, and there were no signs of carbon emissions. The path it took was inherently strange and intriguing. While the idea of Oumuamua being an alien probe gained attention in the media, it did not stand up to scientific scrutiny. First of all, if it were a probe, it would probably emit some kind of radiation or signals, but none have been detected. Additionally, its tumbling motion does not align with the expected behavior of a probe designed for steady motion or data collection. Additionally, the object's path may be explained by natural phenomena, as in the theory presented by Jennifer Bergner and Daryl Seligman, proposing Oumuamua is a hydrogen-rich comet, explains its unique characteristics, and does not require extraterrestrial intervention. The notion that Oumuamua might be an alien probe taps into our shared intrigue with the mysteries of the universe and the potential existence of intelligent beings beyond our planet. However, it also serves as a reminder of the need for thorough scientific investigation. While speculative theories can be captivating, they run the risk of diverting attention from more credible explanations. Despite the perplexing features of Oumuamua that have left astronomers puzzled, the most likely explanation points to it being an uncommon type of comet or asteroid. Its extended journey through interstellar space likely led to changes in its composition, resulting in the formation of a crust that trapped the majority of the frozen gas. This explanation aligns with the distinctive characteristics observed and finds support in data collected by NASA's Spitzer Space Telescope. The identification of Oumuamua carries significant implications for our comprehension of interstellar entities. It implies that an immense number of such objects, possibly trillions, might be traversing our solar system, and our ability to detect them is only in its infancy. The Large Synoptic Survey Telescope, LSST, in Chile is poised to play a crucial role in this pursuit. The full commencement of survey operations is scheduled for October 2024, owing to delays linked to the COVID-19 pandemic. Once operational, the LSST holds the potential to identify more objects akin to Oumuamua. The plan is to make LSST data entirely accessible to the public within 2 years, presenting new opportunities for unraveling the mysteries of these intriguing interstellar visitors. Looking beyond telescopes, advancements in propulsion technology and data analysis hold the promise of allowing us to explore and examine interstellar objects in much greater detail. Envision a future where we could deploy a probe to rendezvous with an interstellar object, gather samples, and transmit real-time data back to Earth. The recent approval of the European Comet Interceptor mission marks a significant stride in this direction. The European Comet Interceptor mission stands out as a groundbreaking initiative enhancing our capacity to study interstellar objects such as Oumuamua. Unlike earlier missions primarily focused on objects within our solar system, the Comet Interceptor is meticulously crafted to gather data on celestial bodies originating from beyond it. Led by the European Space Agency, ESA, with collaborative support from the Japanese Space Agency, JAXA, this project is poised to investigate a comet that has spent minimal time in the inner solar system and might be on its inaugural visit. This mission represents a step forward in our ability to explore and comprehend the mysteries of interstellar visitors. The space mission is set to launch in 2029 and will include a primary unit and 2 probes specially designed to observe a comet from various perspectives, forming a detailed 3-dimensional profile of the mysterious target yet to be discovered. This exciting mission will join ESA's aerial exoplanet mission as it ventures into space. Once in space, the Comet Interceptor will patiently await a suitable target at the L2 Lagrange point, located 1.5 million kilometers behind Earth from the Sun's viewpoint. Positioned there, it will be ready to intercept upcoming interstellar objects passing through our solar system. Upon detecting such an object, the spacecraft will skillfully adjust its trajectory to execute a close flyby, capturing detailed high-resolution images and gathering valuable data on the object's composition, structure, and even its origin. The identification of Oumuamua marked a groundbreaking moment in astronomy, sparking questions about the frequency of hydrogen-rich objects in the vastness of the universe. Are there other interstellar objects out there with diverse compositions and behaviors? And perhaps most crucially, how can we equip ourselves to more effectively investigate these objects in the times ahead? This discovery has acted as a herald for upcoming revelations, pushing us to ready ourselves for fresh interstellar guests that could be just as mystifying, if not more so. It's a call to arms, urging us to be proactive in our preparations for the potential mysteries that the cosmos may unveil. In today's video, that's all for now. See you in the next video,